Welcome to another video by AskMath.com. Let's read the directions to this problem. How many solutions does the system of equations have? Given negative 8x minus 8 equals negative 2y and 3y equals 12x plus 6. So let's remind ourselves what we're being asked to find here. A solution to a system of equations means, let's start with system. Anytime that you have two or more equations, like these, that's called a system of equations. And anytime those equations have math such as addition, subtraction, multiplication, and division in them, like these do, but don't have any additional math like, for example, exponents, then those equations will create straight lines if you were to graph them. And when you graph two straight lines, there are three possible outcomes. One is that you could have parallel lines, and those never cross each other, and so that would mean that they have zero solutions. A solution is where the two lines would cross one another, so these would have zero. Another possibility is that you could have two straight lines which cross each other at exactly one point, and that point is called the solution, and it has coordinates of x and y. But in terms of how many solutions or how many points they cross each other, there's just one. And the third possibility is that you have two straight lines where you graph one of them, then you graph another one directly on top of it, and that means that both lines intersect each other or cross each other at every single point along the lines, and so that would be infinite solutions. And there's no other possibilities. Because the lines are straight, they can't cross each other at only 2 times or only 3 times, for example. They'll never curve back and come back together because they are straight lines. Okay, so to find out how many solutions there are, in other words, to find out which of these three possible outcomes or possible answers is the answer to this question for these equations, we need to try to attempt to find the solution. And to do that, there are three methods that we could use to see if we can find a solution such as this. One is by graphing, sort of like what we've done here, except maybe using grid paper and a ruler. That's probably the least useful option for most equations. They would have to be pretty simple, fairly small numbers. You'd have to have graph paper and a ruler. So we're not going to graph them. Another method is called combination. And combination works best if when you have the two equations lined up so their equal signs are lined up, if the other expressions in the equation line up with each other so that the y's in the first equation are over top the y's in the second equation. So if we could envision scooting this bottom equation to the right so that the equal sign was underneath this equal sign, that would push this 12x plus 6 to the right, and those would be underneath this negative 2y. So this expression of the y would not line up with another expression containing a y. That other expression in this equation is over on the left side. So combination probably isn't the most, the easiest approach to solve this either. You could certainly use it. You'd have to do a little bit more work first to rearrange these equations. The third method is substitution, and that works best when you have a variable all by itself on one side of the equation. Now we don't have a variable all by itself, but we do have this 3y equals everything else over here. That's pretty close to being all by itself, and with just one fairly easy step, you can take this 3y, and I'll just rewrite the equation here, and you ask what's happening to the y, it's being multiplied. You can undo that by using the inverse operation, and the inverse of multiply is divide. So we're going to divide, and we're going to divide by a 3 to get rid of that 3. But before we do that, don't forget that whatever you do to one side of an equation, you have to do to the other side. And when you say do it to the other side, that means everything on the right side of that equal sign. So we have to divide the entire side by whatever we do over here. So we divide by 3, we divide this side by 3. The result on the left side is 3 divided by 3 makes 1, and 1y, you can just write y. And that was the reason that we did this. We wanted to get y all by itself. And then on the right side, don't forget that when you're evaluating an expression, you use PEMDAS, the order of operations. And when you evaluate or simplify, you use PEMDAS forwards. So there's no parentheses, so we don't have to worry about that. There's no exponents. There's no multiplication, but there is division. Divide by 3. So we have to divide this 12x by 3 and this 6 by 3 first before we worry about the addition. So 12 divided by 3 makes 4. And so we get 4x. And 6 divided by 3 makes 2. And so now we're done simplifying. We have done the division. We can't do the addition because we don't know what x is. So you can't add an expression with a variable to an expression without a variable because you don't know what x is. So we'll stop right there. And we're actually done simplifying or evaluating. And so now we've got y all by itself, and we know that y equals this stuff. So now here comes the substitution step. So we said we're not going to graph, we're not using combination, we're using substitution. And to do that, we had to get y all by itself. We're going to take that stuff that we got from this first equation, and we're going to substitute that stuff that y is into the first equation here where the y was. So let's rewrite the first equation, negative 8x minus 8 equals negative 2 times, put your parentheses, and now here's where you substitute the stuff that y is in where y was in the other equation. Now we have an equation that doesn't have any y's in it, and that was our goal. You can't solve an equation that has 2 or more variables in it. You can only solve an equation that has 1 variable in it. So now that it does, we will be able to solve it. But first, we have x's in more than one place, so we have to simplify this equation now a little bit more. And to simplify, we're going to do the only math that we can do on this side, which is distribute or multiply at negative 2. And we multiply negative 2 times 4x. Negative times a positive makes a negative. 2 times 4 is 8 times x. And then a negative 2 times a positive 2. Negative times positive makes negative. 2 times 2 is 4. The other side doesn't change. Now we need to collect our variables onto one side of the equation. So we don't want x's on both sides, we just want them on one side. Now to do that, we can't simply combine these, and the reason is that there's an equal sign in the middle. If these were both already on the same side of the equal sign, then you can go ahead and combine them. But when they're on opposite sides of the equal sign, you're only allowed to do an operation to remove them from one side and then do the same operation to the other. So pick a side. I'm just going to pick this right side. I want to remove a negative 8x. To do that, I'm going to use the opposite, which is positive 8x. That's the inverse operation. And then whatever I do to this side, I have to do the same thing to the other side. Okay? And so this makes 0, and that was the goal, so that we're left with a negative 4. Don't forget to keep that negative sign with the term to the right. And then it just so happens that on the left side, that also made 0. So we did this on purpose to make 0 here, and it was a coincidence. We ended up with 0 on that side as well, and all we're left with is negative 8. So now you might think, oh, wait a second, I think I made a mistake, but no, you didn't. Okay, so we've got this equation, and there aren't any variables left. So let's remind ourselves what the possibilities are over here. If you could find an x and a y value, then you would know that there is a solution, and you would say the answer is there are 1 solutions. However, our x's and y's have all disappeared, and so there is not 1 solution. So the only other 2 possibilities are 0 solutions or infinite. And when you get this statement, you have to evaluate, decide is this true or false? Does negative 8 equal negative 4? And that does not, so that's a false statement. And a false statement means that there are 0 solutions. It means that we have parallel lines. If it were a true statement, it would mean that there are infinite solutions. So because it was false, And false means 0 solutions. 0 is the answer to this question, how many solutions? And there are 0 solutions. All right, that's the end of this problem. Thanks for watching another video by AskMath.com. Make sure to check out all the other videos on AskMath.com.